My name is Mark Sobkowicz. I'm a high school teacher at Lincoln-Sudbury Regional High School. And Lincoln-Sudbury is about 20 miles west of Boston. And Lincoln and Sudbury are directly adjacent to Lexington and Concord. So if you're from anywhere in the United States, you've probably heard of Lexington and Concord. And if you're from the UK, that's where your butts were kicked the first time. Although, I guess there's very little animosity left, I think. So Lincoln-Sudbury is it's a medium-sized high school. We teach computer science. I was hired in 1995, and I learned yesterday that 1995 was the year that Ruby was released, and that was the first year I started teaching at Lincoln-Sudbury. How many of you have been working in the same job since 1995? Okay. I was hired to teach physics, and I actually still teach physics. So I started just as a full-time physics teacher, and then in 2000, so 5 years later, a guy who was teaching programming left, and they knew that, somebody knew that I had done some programming when I was a physics graduate student, and they asked me if I would teach the Intro to Programming course. So the Intro to Programming course is just, we try to bring in as many kids as we can. It's a one-semester course. It doesn't meet as much as some other courses. So the elective courses at Lincoln-Sudbury meet a little bit less. And we also teach some upper-level computer courses, generally one that sort of parallels the AP. It's not called AP Computer Science, but whatever language the AP uses. And a bunch of the kids actually end up taking the AP exam from the upper-level course, but not from the intro course. So when I was teaching it, the first year, a couple of years, we used Microworlds Logo. That's what they had started with when they started teaching Intro to Programming. Some of you have probably seen logo of some sort or another. The Microworlds version gives you a little IDE to build your apps, and the turtle moves around. And you start by moving the turtle with the kids, and with little commands like forward and turn left, and then you can dress it up with costumes, and so you end up with little games. Of course, the turtle is now hidden by the costume, and you end up with little games with that. To use this in a high school, the kids would make some pretty sophisticated things. I mean, not super sophisticated, but you can do quite a bit with Microworlds Logo. But we had the sense that the kids thought it was a little bit childish. They had used it in middle school, many of them, because the middle school had picked up a little bit of programming. So I just felt like they thought it was childish. They didn't do it outside of class. They, thought it was cute, but just did it as part of the course, and I wanted something more. We switched in 2002, I think, to using an environment called Real Basic. Real Basic is a little bit like Visual Basic, maybe, but it's sort of Mac-centric, although it's cross-platform. And you build windows with these widgets, and you program them with basic script. It's pretty object-oriented. It's not like, it's not the basic you might have learned in 1985, like I did, but it kind of worked for us. It's proprietary, which means the kids, if they wanted to use it at home, had to buy a license. And I think that was something of a negative. We're having trouble, though, filling the courses, right? I'm not sure what it was. I still, cause and effect are hard to tease out of things like this. Intro to Programming is an elective course. It's competing. Well, it is kind of competing against things like woodworking and pottery and drawing and web publishing and, digital imaging. And there's a whole range of fun, interesting courses kids can take at Lincoln-Sudbury. And if we want them to take Intro to Programming, we have to make it, enticing to them to do so. Some of them were definitely taking it because they wanted to be programmers. But our goal really with the Intro to Programming course is to gather in people who didn't think they wanted to be programmers and maybe show them what it's like, or, not even, the goal isn't really to just generate programmers or anything. It's just to show people programming who wouldn't normally see it. So we had trouble filling the intro course. The intro course feeds into the upper level courses for several years, from from like 2007 to 2010, we weren't able to run the more advanced intermediate course, which is now in Java. It was in C++ when I started, I think. Might have been in Pascal like the first year. But the upper level course is now in Java, and we weren't able to run that for a number of years in a row. So I decided, it was my decision at that point, I was the department coordinator for computers, and I talked to everyone else, but there's about 4 of us who teach computer courses. I decided that we would try to go to Ruby, and I had been using Ruby. I took a course on Ruby on Rails at the Big Nerd Ranch in 2007, I think. And I'd done some sort of personal projects, and I took an advanced Ruby course. I get to take a lot of courses because the school is really supportive of summer professional development. So I can usually get money for like a summer course most summers. And so we decided to switch to Ruby and try to teach kids in Ruby. So we started using Ruby. I did a little pilot the year before with about 5 kids trying some different things. We took a look at shoes. We took a look at some of the stuff I'm going to show you. Just to see what I thought. The kids were excited to do this small group thing, and I just did it as an extra. And we started, all the intro courses moved to Ruby in the 2011-2012 school year. And all the code you're going to see, except a few like just skeleton things, are written by high school students. So you can see the student who wrote this, right? They had just learned, I just said, I think, something about indenting and tried to explain, right? That code should be indented, and I tried to explain when and where. I'll talk about the tool in a minute, but I like the fact that it doesn't do the indenting for you, that you have to do the indenting. It's a little bit annoying after a while, but still, it gets them to sort of think about why when they're trying to debug their code. So in order to teach the course, we had to pick some tools to use, and we had to develop some curriculum. And of course, you're not developing curriculum from scratch. There's a lot of stuff out there. But the tool that we picked, although we looked at TextMate, I think we decided that Sublime Text was too expensive. But the tool we picked was Code Runner. I think it was $10 on the App Store. And I have to buy 30, so you end up spending some money. Code Runner is it's really simple. It takes, and you can use it with a plethora of languages. Basically anything you can run at the command line. This is just a stand-in for the command line, right? It's a little editor, and then the run just essentially runs it at the command line and shows you the console in a simpler way, in a way of right in the same window. You'll see that soon. So Code Runners have been a great tool. And again, it doesn't do any of the indenting for you or anything. It does a little code coloring. That's all it does. So then that summer, before we really did it, I used some of the stuff from the 5 kids that I worked with the year before, but I had to develop a lot of exercises. And exercises are the hard part, of developing a course. I mean, you can decide what order you're going to teach. You're going to teach like conditionals before loops, or loops before conditionals. Are you going to teach arrays? When are you going to do that? Are you going to do it before classes? Are you going to do it after classes? All that stuff you have to decide, but the hard part is designing good exercises. We create exercises in pairs, one that we're going to demo all the way. Every line of code we're going to show them how to write. And then they have to write something, then another exercise that they have to do with lots of parts, and it has to be interesting, and it has to be clear. So really, if you write a poor exercise, that's the killer, right? If your kids are confused at the end of the day about what they're supposed to do, about how to do it, it's probably because the exercise was not well designed. So that's the hardest part. Each exercise, you want it to have, they're trying to learn something, right? They're trying to learn about if, else. And at the same time, you want it to be something that they can express themselves with. Like early on, there's an exercise where we make a word game, right? Where this is like almost the second week, right? And what their word game is supposed to do is gather input from the user, like a Mad Lib, right? You can't use the word Mad Lib because somebody's trademarked it, but they're supposed to, give me the program says, give me an adjective, give me a noun, give me a color, give me a food, and then it generates a story out of those words. And so they're learning how to do a little bit of input-output. That's really all they're learning, and string manipulation, but very little string manipulation. And then, but that gives them an outlet for their creativity. So we're going to show this, we're going to do them on the projector afterwards, so they're, motivated to make something that'll make their classmates laugh. And so it's pretty fun. The other thing about exercises is that if you make an exercise that some kids, like you're sort of aiming at the middle bottom, right? There's some kids that either don't care or they're, just aren't going to get everything anyway, and you're going to have to chop a few things off for them. But you're aiming at the middle bottom. You think it's going to take 2 hours, right? 2 class periods for them to complete this. There's somebody in that room that's going to do it in 10 minutes. And they're going to have it exactly right. It's not like they're just rushing through it. Some of them are just able to learn it faster. Some of them have a background. Some of them, their parents spent hours and hours teaching them Python, and it's just not that different, right? It's close enough, and they can figure it out really fast. I've never had anybody come to me knowing Ruby except my own kids, because, I taught them. And so the way I try to solve that is by having sort of a list that I don't put on the assignment, because there's nothing more depressing as a student than having this list of like 37 things that you could do, and you don't even get the basic stuff. And so the kids who do it in 10 minutes, you just tell them, right? Do a different thing. Like with the word game, if a kid does it in 10 minutes, that means they're pretty bright, probably, and can probably read a book. So I hand them the pickaxe and tell them that you should write your thing to a file, right? What I try not to do is tell them to do something like we're going to do next. Because if we do that, then when we get to the thing that we're going to do next, then they're already done with it, even before the 10 minutes. So I try to do a side thing, orthogonal things, I think of it as, right? Because it's not along the path we're following, it's in a different direction. One group even did, although I think they ended up finishing it much later, did the word game with the questions and stuff as a Sinatra project. So they had to go and read up on how to do Sinatra, do some tutorials, and then try to build the word game that way with some inputs, and then, So I'll talk a little bit about what the class is like, what happens in the class. Right, so each class I take 10 minutes at the beginning, maybe 15, depending on what we're doing. And I'll either do direct teaching, direct instruction, lecture, whatever you want to call it, usually live coding and talking to them, have them turn their computers sideways. We've got the little super thin iMacs now. So yeah, turn them sideways, and they aren't even there hardly. And then they can watch me live code, but then about the other half, that's about half the days. The other half will do some sort of group code review. Like we'll look at some code that usually the other class, so I've usually got 2 sections, and I don't want to put a kid on the spot, although sometimes I'll ask, if something is really interesting, I'll ask the kid if I can use their code on the board. But we'll talk about some code. We'll talk, especially if somebody's stuck on something that seems sort of relevant to everyone. So we'll spend 10 or 15 minutes together at the beginning talking about code. I think it's important to get kids talking about code in that kind of way. And I'll, not necessarily put kids really on the spot, but so then the rest of the time, 45 minutes, they're working, because they don't work on this outside of class. This is an elective. I'm not really even allowed, but there's no real way to give them homework. I do teach them how to set up Ruby on Windows. I have a computer with Windows so that I can just demo that really quick with them so they can get it at home if they have Windows. If they have Linux at home, I figure either they can do it or they shouldn't have Linux. And I've only had a few kids actually use Linux on a day-to-day basis. Most of them have Macs, actually, at Lincoln Sudbury, and iPhones. So I walk around. Oh, we got a little ahead of my slides here. All right, so we teach one way to do each thing. Right? There are lots of ways to write conditionals in Ruby, but we just teach one. Right? If, there's no else if here, but else if, else end, with blocks. Right? No inline ifs, no ternary operators, none of that. I don't teach them that there is only one way to do each thing. I make it clear that there are other ways, and that especially when they're reading other people's code, right, they're going to see other ways. But we only teach them one way, and then when they're doing the exercises, we expect them to do it that way. Now, some of them will go off the reservation and do other things, right? They will do crazy things that they find online, and then I tell them they're kind of on their own. Like, if you're going to go online, that's okay to look for solutions, but you have to understand what you find, and you have to implement it correctly. Or you can do it my way, and I'll help you. So then I'm walking around the room, because 25 of them, 26 sometimes, we have 26 machines in the main area, are working. Right? We have a few extras. If one breaks, we can swap it in. So they're working on their projects, and I'm walking around looking over their shoulders, and they're raising their hands because they have questions. And they have questions their questions are debugging questions, right? You can see name is spelled with a capital letter in line 3. And the most confusing thing for kids is not the code. The code reads pretty well. You know, once you learn the difference between equals and equals equals, that's a horrible thing for kids. Even after you tell them the third or fourth time, sometimes they're doing it wrong. But the debugger, the interpreter, the errors aren't that helpful. That's not helpful to a kid. Except I try to teach them to use what's there, right? There's two things there that are useful. One is when it's quoting your code, name, that's probably the problem. And then it also is telling you what line the error's on. So if you have a long piece of code, it's probably telling you what line the error's on. Except the scourge of my life is the missing end statements. Right? Because it doesn't tell you anything. It just tells you there's a missing end statement. So you have to find it yourself. Now this is short, right? I can't show a 70-line piece of code that a kid has written, but there are examples with these, they'll go pretty complex, and somewhere there's an end statement. I could find this one in a minute or less, and it's indented correctly, which helps a lot. But they can't. Right? And theirs is unlikely to be indented correctly. Usually the kids who can indent correctly are also the ones who can find the end, strangely. Right? But, so I teach them a strategy, right? And I hardly ever debug their code. Sometimes if a kid has struggled with something for a good half an hour, I will debug their code. I will find the problem because they just need to move on, and I don't really want to turn them off completely. So I teach them a strategy, and the strategy I teach is to comment each if, while, def, and class, right? Each thing that's going to have an end, and then try to match them up. And then it kind of makes it clearer what's missing. So comments, I make them put it. I don't use comments a lot with kids. I find they should write code that's expressive enough that comment at this level, right? That comments aren't too necessary. Sometimes I ask them to put in some comments about a method or something and why they chose to make that method. But here's a place I definitely use comments, is when they're debugging their own code, I ask them to use comments. Then there's the debugging where the thing runs but doesn't work, right? And then I tend to have them use puts and print to the console and try to get some information about what's going on. Those can be harder too, especially when the algorithm's reasonably complex. But mostly we don't do anything that complex. I make screencasts of the basic lectures. So because if a kid misses a class and they miss that 10 minutes of direct instruction, then I can just point them at the screencast. Or if they, some kids need to hear it more than once, and I don't really want to teach it again and again and again, and I can't because there's one of me and there's 25 of them. And I call it dry teaching. That's really a joke. I don't think that dry teaching is even something to aim for, right? You do have to repeat yourself. But this I think of this more as a way to repeat myself without having to go insane. So they're really helpful because you've got 25 and they need different things, and you can point them at the screencast, and they definitely use them. I can tell from how I walk around the room and see them using them. So the second half of the course is video games, right? We have some basics. I'm not going to say we have all the basics. That would be crazy. But they have some basics of Ruby, and they make video games. I use a gem called Gosu. It's a wrapper. This is a lot like processing. I was looking at the processing thing, and I was like, wow. At least the structure of how you do it is really similar. You're not drawing much. Gosu has very little native drawing stuff. You can draw rectangles, I think, and a few other things, maybe ovals. Maybe that's all there is in processing. But you can use PNG, image files, and that's what they do mostly. All the images in those games are just PNGs that they just make real quick. It's really stable. It runs really well. It opens a native window on Mac, so I don't think it uses Java Swing. I think it uses UIKit. I'm not sure. I've only taken little dives inside the code. It's open source, so you can take a look. And so you can see this is my code. This is the only code that's not written by kids. This is the skeleton I give them, right? It doesn't generate it for you. There's no new. And it looks a lot like the processing thing, right? If you were here for Joanne's talk, you have an initialize, which is like a setup. It runs one time, and then instead of just one update, it runs update, and then it runs draw, and then it runs update, and then it runs draw, and it goes forever until you stop it or it crashes. But it doesn't really crash much. So it runs update and draw. And so we save. I hold back some of the even fundamentals for while we're doing this, because I think that games are a great way to teach about classes and objects. The brick class is just like, it's a solid concept. Like you get it, right? Those bricks in that game that we saw a minute ago, this is the code for those, right? Or it's like the beginning of the code for those. It has its own draw method, right? That I didn't show, but I ran out of space. So, and you can see it's Ruby. You're writing Ruby, and there's a few calls out to the Gosu stuff, but to the Gosu library classes, but very little. Mostly you're writing Ruby. We also teach arrays. This is also from that brick game. Right, we save arrays for the games. Could teach arrays. We could try to squeeze them all in, but then we'd only have a little bit of time for the games. And I find that the games really grab the kids' attention, and I've already spent 10 weeks with them on the basics, and I want to spend 10 weeks writing video games with them. And this Gosu is pretty good. It lets me do that. The kids spend 4 weeks-ish at the end with writing a final project. So basically, we just go through a couple of quick tutorials in Gosu, one with classes and one with the arrays, and then I just cut them loose to try to come up with an interesting final project. So they make a proposal for their final project. They often work in groups of 2 or 1 or 2, a little bit of pairs. I wouldn't call it pair programming because I insist that they each sit and write all the code. They should talk to each other about what they're going to do and how they're going to do it, but they should each sit and write the code. They shouldn't copy the code over to each other. And this is somebody's final project. See the quality graphics? Good choice of fonts. And there's the game. So he was really pretty good. The animations of the wheels and stuff, he asked me, he came and said, well, how do I do, because the bullets and stuff I show them how to do. But he wanted to know how to animate the wheels. And I just said, what if you put a bunch, instead of having one image, what if you had an array of images? How would you then implement like an animation, a little animation? And that's all he needed. So that was great. I thought it was supposed to loop, but. So each of the last couple of years, right, we only started a couple of years ago, we filled 4 intro to programming classes where we had been at like 2. And cause and effect is hard to tease out. Tech's kind of hot, and kids kind of know that. So maybe that's pulling kids in. I hope, I'm happy with whatever pulls them in. So about 25% of our kids, if this continues, are getting an intro to programming class while they're at Lincoln Sudbury. Now I am a little sad that I don't get as many girls as I get boys. It's not a disaster. It's not like I have classes with no girls. It's about 25 or 30% girls and the rest boys. But of course the school is equal, so I think that it should be about equal. But so far it is not. And anybody who has concrete ideas about how to get them to do it, I would love to hear those. So I gave my current students who took Ruby last year a survey and asked for some feedback. So that's where some of these little quotes from kids come from. And last year, which was after the first Ruby, right, our Java programming class was the biggest it had been I could remember. And that was good. Now, because kids can take this class in 9th grade or 10th grade or 11th, so the Java class, there was some pent-up demand for it. And rather than running it again and maybe only getting 10, and that wouldn't be enough to run a class, right? It's in these budgetary times, we have to fill our classes to justify having a teacher in front of the room. So, so instead of doing that, we offered iOS programming this year. The iOS class is not a half-year class, and it's a full-year class, and it meets 4 times a week. So it's about 3 or 4 times as many meetings as the intro to programming class. So it's, it is a much more challenging class to teach. And all the kids have had at least the Ruby. Many of them also had the Java last year. So we wanted to, let those kids have something else to take. It's been fun. I'm teaching the iOS class, and it's fun, having to develop a lot of curriculum. There's a lot out there, though, a lot of good tutorials and stuff. So that's been fun. And we're sharing the Ruby course. I'm sharing the Ruby course on iTunes University, so you can see it. All the screencasts and basically most of the exercises are up there. So, and something like 4,000 people have signed up, although I get occasional emails. Maybe once a week I get an email from somebody somewhere in the world who's checking them out and has a question. So it's not a burden or anything, just answering that many. But that's been fun, putting it up there. And it's a good way also, just like it started just as a way to distribute the videos. Like I had them on Vimeo and on my website, and that was working kinda. But this is really nice because you just open any browser and the videos are right there. So they're just distributing them for me. So this is an interesting question that's been in the news actually. I don't know if any of you have noticed when this came up, but there was a proposal, or at least some pressure on Massachusetts lawmakers about getting every kid computer science. And I don't actually have a strong opinion about the answer to this question. I think that the biggest problem, if you wanted to do this, if you wanted to get computer science to every kid in Massachusetts, there would be a real shortage of people to teach them. I think that some people think that things like Code Academy and Code School and stuff like that, there's free stuff out there, those are good. But I don't know if they're enough without a teacher to answer questions. Maybe they are, but you know, and if kids are motivated, often that's all it takes, right? If you want to learn to do something, then these either online tools or some of the online courses, the massively, you know, like I'm using some of the material that Stanford put out for their iOS class with my iOS kids. It's a little bit above their heads, but it's, you know, sometimes useful for them to see it. But they have to want to learn it for that to be at all useful, I think, which is not always the case in high school. So it'd be interesting to see what would happen if they tried to do that. I'm not sure there's enough teachers out there right now who know enough to do it. And thank you very much.